So here we have a precipitation reaction. Let's talk about the different kind of equations we can pull out of that. So what's the molecular and net ionic equations if we take aqueous sodium chloride, the NaCl, aqueous phase, and aqueous silver nitrate, aqueous silver nitrate, and see what they become. So over here on this side we'll have silver chloride in its solid phase, which we'll explain the importance of that in a moment, plus the sodium nitrate, the cation and the anion bonded together. They'll be in the aqueous phase. So let's depict what happens here. What we do is we have the sodium chloride in an aqueous solution. What aqueous means, it just means that it's been dissolved in water. It is a water solution, a water mixture. So if you put sodium chloride up to a certain point, it will dissolve and become its ionic components. The ionic components are the Na, which the Na's ion would be Na plus. It has a positive 1 charge. It's in the first alkali metal group on the periodic table. And then chloride ion, which is that Cl minus. That is a halide, so it will have a -1 charge, and a positive one and negative one. When they bond, they will form a neutral compound. But if you throw it in water, water being a very polar molecule, the water will separate those bonds between the sodium and the chloride and turn them into their ionic components. So the sodium chloride compound gets broken up into the sodium ions and the chloride ions, with the negative part, the partial negative part of the water molecule facing the positively charged ion, and the negatively charged ion, the anion chloride, would be by the partially positive hydrogens of the water molecule. It interrupts this bond and breaks them into their ionic components. The same happens with silver nitrate. Silver nitrate also breaks up into their ionic components. Well, if you take these two solutions and you mix them together in a larger tub, well, something unique happens. This silver chloride, the silver ions and the chloride ions, which we just dumped into this water, they precipitated out. They became solids. So they fell down to the bottom as an actual solid in this water. The reason being is their bond, the silver and the chloride's bond, is stronger and will not, well, I should take it back, not necessarily stronger, but it will not be interrupted by the water molecules. The silver nitrate, however, it remains in its ionic components. So this, the NaCl plus the AgNO3, yields the silver chloride and the sodium nitrate. That is the chemical reaction. But if we're going to break this up into the molecular ionic equation, we're going to have to put them all into the little ionic components. So we would show that this silver, or the sodium, is going to be in the aqueous phase. Same with the chloride ion is going to also be in the aqueous phase. In fact, all of these are going to be in the aqueous phase, and we have to show all of them as such. The silver is going to form a positively charged ion, a cation, in its aqueous phase, and the nitrate as well, NO3 minus, in the aqueous phase, and then is going to form silver chloride. Anytime it makes something solid, we leave it together like that, AgCl. It's going to be forming solid. And then we're going to have the Na, the sodium. That's still in the aqueous phase. It's still dissolved. Aq plus the NO3 minus. That's also going to be in the aqueous phase. And by looking at this reaction, we see two things on both sides that are the same. We have this sodium ion and this sodium ion here. They're both uh, the same, and then we also have the same on either side of the reaction arrow, and then we also have our nitrate. Nitrate is still in the aqueous phase on both sides of the arrow. So what does this mean? Well, it means that they didn't actually react inside these aqueous solutions. They remained separated. So they are what you call spectator ions, and we need to define what a spectator ion is. So spectator ion. Spectator ions did not participate in the reaction. Do not part does not participate in the reaction. So what we would do after we've written out this molecular ionic equation, this is the complete ionic equation, you could remove these spectator ions. And if we remove the spectator ions, we're going to see that what we did want to look at, what actually did react, was the silver ion plus the chloride ion. These two actually react with one another to form, let's make the arrow green, silver chloride as a solid. Let's see, AgCl as a solid. So when you have these ionic components that come together to form a solid, that is the precipitate. Whoops. That is the precipitate. Grab that. So this precipitate is the ionic components that bond to solidify in the aqueous solution. They actually came together, and we're able to use this kind of reaction to extract silver and chloride from these compounds. And it's a very useful reaction. We use this in many different areas of chemistry so that we can pull out certain components whenever they're bonded together. So the silver chloride is the precipitate, and the sodium nitrate, those are the spectator ions. So how can we tell if they're going to precipitate out? Well, we can look at some solubility tables, and it's a pretty good practice to learn how to read something like this. So I'm going to really quickly, without the phases, put it in here. We had NO3 plus the NaCl, and then that makes that ended up making the AgCl plus the NaNO3. Now, it's supposed to be subscripted threes, but cannot do that in this mode at the moment. So looking at what we had made, we had the silver chloride and we had the sodium nitrate. If we look these up on our tables, we can see if they are definitely going to be soluble or insoluble. So if we find anything like nitrate is always going to be soluble. These are ions that form the soluble compounds. Nitrate is always going to be soluble, no exceptions. So when you look at this compound that has sodium and the nitrate says that it is definitely going to be broken up into the sodium and the nitrate ionic components. But then if we look for something about the silver chloride, we can go down the same list. Oh, there's sodium as well. It's also going to be soluble, no exception. If we come down here, we can see here we have a chloride ion. It said that the chloride anion will be soluble except when combined with, there's our little silver. There's our silver cation there. So if we have silver and chloride bonded together like this, these two things are going to come together to make the silver chloride precipitate. And that is in sum what precipitation reaction looks like. These are the steps to forming your complete and net ionic equations. This one here was the complete, and then this one underneath it is the net ionic equations. Well, thank you.